We continue by looking at a software engineering quality assurance technique known as reviews. Reviews are part of static techniques. So in static techniques we have individual reviews done by one person. We can have group reviews done by multiple persons. But under static techniques we also have tool-based static analysis. We can have source code metrics tools, we can have lints. SonarQube is an example of a tool-based static analysis tool that includes metrics, static analysis warnings, security scanning, and other static analysis measures. The major difference of static techniques to dynamic techniques is that static techniques do not execute the code. So in software testing we always execute the code to ensure that we are getting the coverage measures we need, or when we are trying the different boundaries in black box testing, for example. In static techniques there is no execution of the code. So what is a review? A review is a meeting or a process at which an artifact is presented to peers, customer, user, or other interested parties for comments and approval. And so this artifact can basically be any artifact of interest. It doesn't have to be source code. Goals of the review may include identifying defects and improving quality. This is quite obvious. But also there is chance to educate people and do knowledge transfer. It also enables in presenting and discussing alternative solutions. For example, during a software design review, alternative solutions for a particular problem may be discussed and presented and compared. It is claimed that reviews are a very effective way to do quality assurance. According to some studies, they catch more than 50% of the product defects. Some even claim that they can go up to 90%. So what can be reviewed? Well, we can review software requirement specification, we can review software design description, source code can be reviewed, software system configurations can be reviewed, test cases can be reviewed, both black box and white box test cases can be reviewed, software test documentation, user documentation, system build procedures, installation procedures, release notes. We can also review configurations of automated testing pipelines, and the list goes on. Basically, anything that is written down can be reviewed. If we consider the cost of defects, it is easy to understand that the sooner a defect is found, the lower the cost. There are several sides to this. One is that when developer or other person in software engineering organization makes a defect, it takes then later time to fix this defect. But the defects that are quickly found are faster to fix. For example, if developer makes a change to the source code, but only an hour later other developer points out that there is a defect in the source code. Now it is quite quick to make this fix because the developer still has in their mind on what they were thinking when they were developing that source code. So they don't have to try to familiarize the source code again. Compare this to the situation if you have to fix a defect you have made maybe 1 year ago. You have totally forgotten the source code around it, unless you are still working on it. But let's assume that you have moved to another totally different project in a company. So then they are asking you a year later to fix a bug you have made. So it is your bug, so it is your job to fix it. But the problem is that now you have to start reading the old source code and starting to think about, okay, how is this software even working? What is going on here? Because, in a year later, you won't be able to remember the details as accurately as you remember when you are currently or just few hours ago have been programming them. And remembering these details is very important when you are making the fix, because otherwise you cannot make the fix unless you understand the source code. Another dimension to this cost of a fault is the fact that if you made the defect 1 year ago, it has already caused problems in the customer's end. So there has also occurred cost in the customer's side, because the software was not working correctly and it has caused problem in the customer's end. And then the customer has contacted the support would have to look into the defect, and many process steps have been taken place before the defect is back in your table. And all these process steps cost time and money. And this is in comparison to when you would have just 1 hour later fixed the defect. Now all of these costs would have never happened. They would have never occurred. So from this background comes this image from Barry Beam that presents the relative cost of a fault. So we assume that the cost happens in the requirements phase. So in the requirements phase, if you catch the defect immediately, the cost is 1. But if you go to the design phase, now the cost of a defect is 5, because you have already worked on the defect. You have worked on the faulty requirement and you have made design based on it. And somewhere in the design phase you learn, aha, this is incorrect. And now this cost keeps increasing the further you go down in this sort of waterfall type of development. If you go to the coding phase, well, then you have created already source code based on the faulty requirement. So now there is even more cost for the defect. In the development testing, you have created the coding completely and you have completed some testing, and now someone tells you, no, this requirement, it is incorrect. It is not actually like this. We need to change everything. And if it goes to the operation phase, well, it means that the software has been already delivered to the customer. So now there is a cost for that defect already in the customer's end, because the customer is wondering, well, this is not supposed to work like this in the customer's mind. Of course, the requirements say it's supposed to work like that, but that is because there is a defect in the requirement. So really the benefit of the review is that it can be done immediately when something is written, and then the cost of finding and fixing a defect is very low. Reviews also target this sort of requirements, design and coding phase. So, if there's a defect in requirements, the reviews can work here and catch the defect when the cost is low. But if you catch the requirement defect in dynamic testing, well, then the cost of that defect has already gone up considerably. Some benefits of reviews are listed. So, one of the main benefits is that it can be done as soon as the artifact is written. So as soon as something is done, you can review it. You can easily apply this to parts of the system or incomplete components. I mean, the source code does not even have to compile and you can still review it. It is possible to consider other quality attributes that cannot be seen in software testing. For example, software reusability, maintainability, and modifiability cannot be revealed by testing. They can only be revealed by code reviews. Also, security issues is something that can be revealed by reviews. Another benefit is the distribution of knowledge. So it's possible that the reviewers do not completely understand the source code they are reviewing. They might be, for example, junior programmers in the team. But when they review the source code, well, they get some type of understanding, and during the review meeting, they can ask about more details about the source code, and this way they can learn from their senior developers. The defect isolation time in code reviews is 0. So basically when you see a defect in the source code, you have already found the location of that defect. Now, this is different to software testing, where you just find that, okay, the software does not work, but then the next step is that you have to identify, okay, so in what line in source code is this defect? And this can, in a big and a large software system, this can take, hours. And I have even personally witnessed debugging sessions of trying to find the faulty source code lines that have taken weeks in a certain very large piece of software. Reviews can be organized in different ways. If we say that you organize an inspection, then you are referring to the most rigorous, the most effective, and also the most expensive type of review. In inspections, the focus is on defect detection and measurement. With inspections, there are two phases. There is the preparation, which basically means a single person review. So everyone in the inspection team reviews the document. After the single person review, the multiple single person reviews, there is an inspection meeting during which the defects are, during which the document is gone through. And all the defects from the different individuals are collected. So inspection type of review is very heavy on the process. It has different roles and it has lots of rules and regulations on how to conduct it. The same type of approach can be done also with the team review, but with less administrative hurdles and with less process. So here is the same idea. Everyone in the review teams reviews the document, and then there is a meeting to go over the document. And this document can also be source code. So when the focus in inspection is defect detection and measurement, and they even explicitly say that you should discuss, for example, design alternatives. In team review, it is not so rigorous. So there is possibility to educate, discuss better design alternatives. And it is a more relaxed version of the inspection. So then there is the walkthrough. And the difference here is that there is no preparation in comparison to inspection or team review. So no one prepares for it. It is simply an event where the author of the document or the source code has a central role in presenting, and the other ones are there to do review, to point out comments, but no individual preparation is done. Then there is peer review, which is basically a single person review. So you send or share the artifact with some other person for review. And if you do a pass around, well, basically it's a multiple concurrent peer review. So you send the artifact to 3 other persons for review. And well, the modern patch review is of this nature. So you submit the patch that you want to get accepted to the version control main trunk, and then multiple concurrent reviews take place where the source code is reviewed before the patch is accepted. And finally, I have listed pair programming here as well. So in that, 2 persons work in one computer to program. And we could say that this is also sort of continuous review and continuous development. It is a different nature because you are jointly creating the artifact. But still, we could consider that one person is always the driver, the one who is currently has the keyboard and is writing the source code, and then we could think that the other person is a reviewer of what the other person is writing.